Let's click to that one, shall we?
Oops.
Oh no, we broke physics again.
We need a new galvanator.
It's definitely moving.
There we
Oh,
go.
whoa.
I think there's a dodgy connection in there somewhere. Turn it to there, and then back to there, and then... It really doesn't want to go the other way, does it? A little bit. Well, so you believe me that one way the current goes positive, the other way it goes negative. And so to work out the direction of current flow, we're going to use our same right-hand slap rule, except how are we going to have to modify it to cope with Lenz's law? What way is the force on that? If I push the wire down, what way is the force on that wire? Why is it up?
Because it's balancing.
Because it's
the opposite.
it's a stubborn pig.
Stubborn.
Yeah, it's opposing whatever we try and do to it, it's going to oppose. So if you push the wire down, the force is up. Magnetic field goes what way? From north to south.
Yeah.
So magnetic fields like that. The force, if we're pushing the wire down, the force is up. And so the current flow is going to be that way through the wire. If we lift the wire up, the force is going to be down. Yeah, magnetic field's that way.
Why's it down?
Current,
Stubborn pig.
why is it down?
Oh, yeah.
Yeah, so the key thing we have to remember with induced voltages is that the direction of the force is going to oppose the motion. It's going to oppose whatever change we're trying to make to the system.
Right.
Is that?
Yeah.
Cool. So, induced voltages, like voltages that are created by a wire moving through a magnetic field. And we've got this equation that we puzzled out earlier, the V equals BVL. We're really careful about the big V, little v thing. Big V's voltage, little v's velocity. We're really careful not to get them confused. What we've found is that as we move a wire through a magnetic field, a voltage is induced across that wire. And that voltage causes a current to flow. Current flowing through a magnetic field causes a force. And that brings us to Lenz's law. Lenz's law helps us find the direction of that current flow. Lenz's law is that the induced voltage will create a current flow that will create a force that will oppose the change that's taking place. The key thing is that it opposes the change. So let's have a little look at an example. We've got our blue thing, there's a wire, and it's moving down through a magnetic field. What direction must the force be on that wire? By Lenz's law, good. By Lenz's law, the force is going to oppose the change. The change is the velocity, and so the force must be upwards. And now we can apply our right-hand slap rule to find the direction of the current. What way is the current going to flow? Good. Fingers are field. Slap is the force. Thumb is the current. So with that set up like that, we're going to have the current flowing to the right. The induced current flow. So this is how generators work. This is how we make electricity, right? We move wires through magnetic fields. That makes electricity. This is how we run the world.